Okay. Today, working with radicals part 1. If you go to the website, this would be printed out for you. You could print that out. I'm not saying you should. But if you like to save yourself just a little bit of writing, every day I put the PDF up and you could print that out and then you could fill the rest in. Working with radicals part 1. When the lesson's over, I put the completed version up along with the video. Okay, so all that stuff should be there when you look. Multiplying, dividing, and simplifying square roots. 2 of those 3 are really easy. 2 of 3. Multiplying square roots. Here's the property. If you have square root of a times b, you can break it up into 2 separate square roots. If it's multiply inside. If it's multiply inside. Or dividing. But anyway, square root of a, b. Then it says prove it. Prove it, you say. How am I supposed to prove that? Well, you could get some numbers out and see if it works, but that's not really proving it. I'll do that. I'll do a quasi-proof over here. In a thought bubble. Excuse me, recorder thing, you move up there. Here's my little bit of thinking. Here's what I'm trying to prove to you. Is square root 2 times square root 3, is that square root 6? Does that work? Boy, it would be nice if it did. So I get my calculator out and I go, let's find out if it works. Again, this is not technically a proof. A proof goes, this always works. I'm just going to prove it works once. And this is going to make me feel good about the situation, that this is going to work. So I'm going to go root 2 times root 3. Look at the calculator, it's like, it's root 6. Making me feel really good about the situation. If your calculator doesn't do radicals like that, if you get a decimal, you go, okay, 2.449489743. Then you do root 6, and you get the same thing. And you go, oh, that seems to work. Not a proof, but like, looks pretty good. Looks pretty good. And actually, hopefully, after all the stress of last night's homework, you're like, well, that's not so bad. I can do that. It's not much to understand there. Here's the proof, though. This is very interesting what I have to do to use the proof. Square root of AB. Here's what proofs are for you future university math students. I mean, when you get to university, you might have to do proofs like this. This is what proofs look like. You start with what's on the left. You use stuff you know, and hopefully end up at the bottom with what's on the right. I liked proofs in university, not because I'm a math nerd, but because I knew what the answer was. I know I got to get to this. I know what I got to head towards. The only weapon we have available in this is that square root can be made into an exponent. And if last night you were doing homework going, why do I care about switching from radical form, that's a radical, that root thing, to exponent form, here's one of the reasons. I can use it for proofs. The square root can become an exponent. What exponent does square root become? So close. 1/2. Okay, do I do that praying thing to be dramatic and silly? And so you like my class? Yes. But I do that to go, oh, he thinks we should know this. Yeah? He really believes that that's an important detail. Maybe you couldn't do all the homework. Maybe you did the first 5 questions. Pretty good. You didn't get all the way through it. But this better be something you got out of it. So if you went home and did no homework, you didn't address it at all, you might not know that. But if you did a bunch of the homework, you're like, yeah, square root becomes exponent 1/2. I'll re-explain it if you need me to at some point. You can come talk to me. I'm there. I go there lunch every day, and it's not because I don't have friends. I go to 276, and I stand there in the class, and I go, anybody coming today? I look out the door. I'm hoping. I actually do a little bit of work, but I'm there for you whenever you need me. And I don't know who it was. Whoever I was texting last night, both the 11U kids and both the 12U kids I traded texts with didn't tell me who they were. I think that's hilarious, by the way. I know who you are, basically. I'm like, this must be from my 11U class based on the questions people are asking. So I'm there for you. Text me, email me. I'm here at 8:20. Most days, my kids aren't trustworthy. You know, sometimes I don't get out, so fast enough. Come and see me. Ask me 2 questions. We'll get 2 questions figured out, okay? That's what you're supposed to get from yesterday's homework. Once I have that, then I can use exponent laws. I showed you the other exponent laws on purpose. If there's an exponent outside the brackets and it's multiply, I can bring it back in onto each of the a and b. And if you're right with me, maybe your mouth just fell open involuntarily, like, oh, what's going to happen? The exponent laws allow me to prove something about the radicals. That was the big deal about yesterday's lesson. A radical is a type of exponent, and now the laws can work if I need them to. Because a to the 1/2, if I wanted to go back to radical form, what radical is 1/2? Square root. Been in a zillion profs classes. I've seen a zillion teachers teach. They all write something different when they get to the end here, when they finished a formal proof. And again, this is not something we really have to have down pat to the end of calculus. But some people write a little square down there. I don't know. I know Mrs. Mlecki does. She likes a little square at the end of her proofs. I've also seen 2 sideways lines like that, 2 diagonal lines like that. I like this. Therefore, true. That's the favorite one I've ever seen. Therefore, it's true. This always works. I can use that now. I can do this. If I have square root 2 times square root 3, I can make it root 6 if that helps me. Better yet, if I have square root 6, I can break it into root 2 times root 3 if that helps me. So this goes either way. That's new with formulas. See, in grade 9 and 10, we often gave you the formula. Like we'd give you a formula, a equals pi r squared, and we'd give you the r, and you'd figure out the area. Weren't you happy? It was just subbing in. Then in the homework, we ask you one where we give you the area, and you got to figure out r, and everybody's like, ah. But formulas are like that. If it works one way, it works the other way. So that's what this thing does. It works both ways. I'll put that up here. You should put a little arrow on top here. Which way are we going to use this? I don't know. Depends on what we're doing. That's where the examples come in. Do you have questions? I'm only 7 slides for those of you who are feeling it in the second week. I never feel it in the first week. First week of school, I run an adrenaline. I love the first week of school. It's usually in the second week I start to go, this is going to go on all winter. Yeah? And then you got to find your strength, your power at that point. Hey, if I can do it, you can. Oh no, 50? You guys are like 16, 15, some of you. You'll be all right. You'll be all right. Let's try it. Let's go right to examples. Let's just try what this thing can do. Not bad today, not bad. Write root 15 as a product of 2 radicals. 2 radicals meaning root something times root of something else. Why would you want to do that? That's not clear yet. I haven't made it clear why you want to do these things. I'm just showing you can. What 2 numbers multiply to 15? 3 and 5. There is another pair, 1 and 15, but that's not exciting. We usually don't use 1 in situations like this. There are other pairs. We could use 150 and 0.1, but that seems like a stupid thing to do, like to go to complicated numbers. This is nice. Root 5, root 3. All I've shown so far is you could do that if you wanted to. Is that a good move here? I don't know that it is a good move. I'm just showing you could if you wanted to. Then this one is the other way. Use the formula the other way. Root 7 times root 5. You could write it as a single radical. You're allowed to take 7, multiply it by 5, and get 35. But I know some people are annoyed at that point. They're like, why? Why do I care? Why would this be helpful? So I'll do one extra example. Root 10 times root 10. Root 10, if you put in your calculator, is 3.13 something. Wait a minute, do I have that? That's embarrassing if I have that memorized. I don't want to have that memorized. I don't want to be that guy. But let's find out. Root 10. Root 10, if you put it in your calculator, root 10, what did I say, 3.13 something? 3.16. Whew, that's good. I didn't have it memorized. Okay, root 10. See, root 10's a mess. No one wants root 10 in their life. Root 10 shows up at the party, you're like, I'm going home. I don't want any part of root 10. But root 10 times root 10 using this new property I've given you is root 100. And root 100, hey, root 100 can come to the party. We like root 100. What's the square root of 100? 10. So that's a little taste of why this new property is handy. Is sometimes putting the radicals together will be better. I got bad news, sometimes tearing them apart will be better. That's where the wisdom comes in. That's where the homework comes in. It's not good enough to watch me do the lesson and go, okay, I sort of get that. You got to have some experience going, which questions do I do what? Yeah? Any questions on what's going on here? I'm on slide 2 of 7. I know I've been teaching long. Is there any day in this class I haven't taught over an hour yet? There's some better ones coming. Next chapter, it starts to ease up a little bit. You'll get some time in class for once to get some work done. Wow, come on. If it works for multiplying, it works for dividing. I don't know if that's a universal rule or not, but it's pretty close. If you find a property that works for multiplying, it probably works for dividing too. Assuming that A and B aren't greater than or equal to 0. In fact, B can't be equal to 0. More on that next chapter. We won't get carried away with the restrictions. I'll just mention them and go, technically B can't be 0, and then next chapter we'll get right into the restrictions and find out why they matter so much. Proof. Okay, here's what proofs look like. I'm also teaching really basic proofs today. By the end of calculus, I've got to get you where you can maybe do some proofs when you get to first year university. Proofs always look like this. You start with what's on the left, you do a bunch of steps, and you end up with what's on the right. So you know exactly how this has got to lay out. Let me just fix one word. I said proofs always work like this. No, you can take a whole course on different kind of proofs. So it doesn't always have to do like this. But when you're first learning proofs, this is usually what you do. Start with the left, use stuff you know, and then eventually get down to the right. What's the only weapon we have? With radicals. Turning them into exponents. It's the only move in the book. Later on, math will get tougher, and we're like, which weapon do I use here? We only got one weapon here, turning it into exponents. And actually, it works very well. And I'll pause to answer a question that might have occurred to you last night, like, why would I want a radical versus an exponent? Exponents are better for moving things around, combining things, pulling things apart. Exponents are better like that. If you just want the answer, though, radicals are better. If you just need the number, see? Radicals are better here. So that's the beginning of wisdom about this situation. If you're trying to do a bunch of work and combining things up, you probably want to go to exponents. Yeah? Exponents are probably going to combine things up better. But radicals, if I need the number, the radical's probably going to get there easier. That's not a hard and fast rule, but that's basically what's going on. Okay, so, and I gave you a law about this. There's a reason that the course is taught in the order it is. I said, oh, if you've got a quotient or division and you've got an exponent out there, each one gets the exponent. And maybe at that point, maybe you're going to be a proof person. Maybe at that point you're like, oh, it's going to work. You're excited. You're like, oh, it just happened. See? This is why I like proofs. Somewhere along the way I'd be like, oh, I'm done. I don't even need to write the last line because I know it's done. And again, at the end of a proof, some people write a little square, a little double line. Some profs write QED. I'm not even sure what those letters mean in my mind, but some kind of Greek thing or something like that. I just write therefore true. I like that, especially when you're first learning it. Oh, it's true. Now, the rest of I've got this weapon that goes on your study sheet. Get it on your study sheet to go, okay, make sure I've got this available. That's going to come up on the test. Yeah? I design my test carefully. I'll make sure this, somewhere along the way, this comes up. You're going to have to be able to do it. Questions there? Oh, can we do some examples? Sure. This is how it's used. Root 29 over 13. If you want, if it helps you on a particular question, you could break that up into root 29 over root 13. Is that better? I don't think it is necessarily better here. I'm just saying you could. Root 18 over root 3. I could make that into a single radical. Who wants to take a shot at it? What would it be? What would it be when I combine these two? No tricks here. It shouldn't be too bad. The radical law allows you to take root 18 over root 3 and put it underneath as 18 over 3. You can go the other way with it. That's usually the way people have difficulty with it. They know how to do it this way, to distribute the radical, but then you could do it the other way and undistribute the radical and say, oh, I can put a radical over the whole thing because it's division. And in this particular case, it does make things better. This is another taste of why this would be better, because I can do 18 divided by 3 and make that into root 6. Simpler. Simpler now that I did that combining. Do you have questions? Do you need more time? If you've looked ahead, there's actually 2 radical lessons. This is radical 1, and then tomorrow I do radical 2. Listen, if you're a little behind on homework, it becomes important to do radical 1 homework. You might do this homework, you get home tonight like, I gotta get caught up, and you go back and start doing the other homework. I don't think that's a wise move tonight. I think you better do radical 1, so when I teach radical 2, you're with me. So if you got catching up to do, that's what Friday's for. Yeah, the PA day is actually well located. First 2 weeks, you're like, huh. You're like, wait a minute, Friday, Saturday, Sunday, a little bit each day. And if you're having trouble getting motivated, if you can't keep yourself motivated, ask that question when I'm done too. So you got 2 questions when I'm done. What about this test, Mr. Todd? And how do I stay motivated? I've got some ideas. I've got some ideas on how to stay motivated. Okay. More time? Simplifying radicals. Well, this is all news about making radicals simpler. A radical is in simplest form when the number under the root sign, the radicand, who comes up with these names? We don't need that name. I'm not going to be like question 1 on the test, what's a radicand? No. But I mentioned that that's the technical term. So the number under the square root sign is not divisible by any perfect square other than 1. What are you talking about? This particular part of the note might have been better after the examples I'm going to do in a minute. Okay? So let me set up the rules and then use them and then maybe look back at the rules. I'll try to remember to do that. Rules, example, back to the rules. What do these rules mean? Second rule, no fractions under the root sign. What? What do you mean no fractions under the root sign? I'll get to it. And last, there are no radicals in the denominator of the fraction. Now you throw up your hands like, well, how am I going to make that happen? Well, that's why you're paying me to be here. I'm going to show you how to do all these rules. Do you have to do this all the time? Well, yeah, yes. Starting now, yes. Because we want to put them in simplest form. For instance, to give you a motivating example, let's say your little grade 4 cousin comes to you and said, oh, I did my homework. The answer to number 3 is 5/10. You should paralyze at that point and go, yes, it's 5/10. What have you learned so far? Because there is a grade where 5/10, the teacher's perfectly happy. 5/10, great answer, Johnny, way to go. Then there is a grade where it's like, not good enough. 5/10, we need better than that. And you learn, oh, we got to reduce. That's really what we're up to today. Reducing radicals. How can we make them as simple as possible? Make them better. Here's the 3 rules. Number under the root sign is not divisible by any perfect squares other than 1. That sentence makes it look like it's more complicated than it is. Wait till I show you what you can do. No fractions under the root sign. That won't be so bad, actually. And no radicals in the denominator. That'll scare you at first, but then I'll fix it, okay? That's slide 5 of 7. Oh, did I turn off the recorder? Watch me dance, dance in the Sorry. Sorry about that. Screen jumped for a second there. I'm not pausing for questions here because, again, this part could have been at the end. This is just what am I about to do. It's like intro to what I'm about to do. But you need more time? I'm not trying to rush you. Do you need more time? More time. Okay. Chill out, Mr. Todd. All right. Do, 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 do. Do, 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 No, you don't have to ask me about motivation. That's what I'll do at the end. I'll have time today. Talk about the test, talk about motivation. Yeah. Jedi motivation. I'm going to show you some great stuff about motivation. When I'm done, you're going to be like, how come no one told me about this? This guy. Who's got 2 thumbs and is going to help you get motivated? This guy. Was that enough time? Was that enough time? Okay. I lost my controller. Did you steal it? Simplify the following radical expressions. Okay, wherever your brain has been during this lesson, you zoomed out and say, Mr. Todd's right, I should have brought snacks today. I'm hungry. I'm stressed out about my homework. My mom's going to kill me. I don't feel very well today. Am I getting a cold? Take all that up on the shelf for just a few minutes, and let's talk about square root 45. Square root of 45 is a decimal. It doesn't work out nice. Root 49 would have been good. If this was your grade 8 class, I would have put up root 49 and we would have done it. Root 45 is a major league problem because it won't come out to something nice. But I can do better. I can do better. Because if I take root 45, most important sense of the day coming up here, if I take root 45 and break it into 2 radicals, maybe I can root part of the radical. Let's go through the numbers. 1 times 45. Don't use 1. 1's not exciting. 1's not coming to the party. 2 times 22 and a half. No, that's not it. 3 times, 3 and 15. Maybe it's 3 and 15. Maybe you even write that down. You're like, root 3, root 15. That multiplies to 45. Do either of those square root? No, root 3, that's not a perfect square. That's what the sentence was trying to say on the previous slide. That's not a perfect square. Root 15 is not a perfect square. No, sad face. No good. Not helpful. 4 doesn't work. 5 and 9. Can you see it? 5 and 9. I'll even write it in the right order. Root 9, root 5. I've pulled a perfect square out of there. What is the square root of 9? 3. See, we're trying to pull out stuff that we can't take the square root of. Those things that I can pull out are called perfect squares. Here they are. Here's the list. Here's what you're looking for. Here's the suspects in this question. 4, 9, 16. Are you with me? What's the next one? $25. What's the next one? 36. What are they doing? I squared 2. I squared 3. I squared 4. There's your list. If mental math is not your deal, like it's like, I'm not really good at these, that's the list you want sitting beside you when you're doing these. These are the numbers. These are the suspects I'm looking for because I can root those babies. Root 60 over root 5. This is tough because now this question asks you to do something totally different. It doesn't ask you to do what I did over there. It says root 60 over root 5. I can combine those using the new radical property I have. I could make this into root 60 over 5. What I'm doing is checking, does 60 divide by 5? If it doesn't, this isn't very helpful. But 60 does divide by 5. 12. Root 12. Better. That's better. We consider that better. No fractions anymore. Get the fractions out of there if possible. Root 12. So you do root 12 and you get it back, and this question's out of 3, and I give you 2 out of 3, and you're infuriated. You're like, I did it. Miss Todd, come on. Killing me here. Root 60, root 5. Root 65, I even showed you the steps. Root 12, it's beautiful. Check the suspects. Does 12 divide by any of the suspects? 3 and 4, look at. I'm going to forget. This is where I get into trouble. I'm going to forget that last step. I'm not going to check that last step. Well, one thing you could do is do your homework. But if you've got a cool calculator, the calculator can be your somber second thought. Yes? Watch what happens. Oops. That's the AP Calculus calculator. I actually give one of those to everybody to use. They don't get to keep it, but they get to use it. But that's not the one I want. I want this one. And I put the same one up on the screen. Where is it? Here it is. Here's your calculator, or a decent one. Maybe tonight you go to Amazon and order something better once you see this. Check if your calculator does this. Root 60 over root 5. Fraction button, root 60 over root 5. Oh. It'll tell you if you didn't finish this off. Okay? If you, on the test, if I write root 60 over root 5 and you write 2 root 3, I'll give you 0. 0, nothing. I don't care, you can type into your calculator. You didn't take 11U math to type things in your calculator. But it is a good backup. It's there to go, you know, you finish off like, I think it's 2 root 3, and your calculator goes, it's okay. Or maybe you forget to do the step, you go root 12. You type in and go, root 12, and it says 2 or 3. Root 4, root 3. Okay, I got it. Yeah, it's good help. Powerful weapon. And hey, some math teachers I think would be like, don't use your calculator ever. I'm not like that. I'm like, let's use it as the weapon it is to help us out. Root 7 over root 81. You're not going to like this example. Get ready to not like it. This one, I combined the fraction underneath one radical. This one, I'm going to do the opposite. I'm going to break them apart. Now, I don't have a rule here. I know people want rules. When it's like this, do this. When it's like that, do that. This isn't like that. It reminds me of baking. First time you bake pancakes in your life, you're like, 1 cup flour, 3/4 cup milk, you're not even looking at it, this much baking powder, stir, I hope it's pancakes. Get better at pancakes, you're like, it's got to look like that. It's something like that. Yeah? That's these type of math questions. Like, what am I going to do here? You got to be a chef here. You got to like, let's try this. No, this one, try this. Needs a little more pepper. Yeah? Got no set of directions here. Just try the radical move. Because look what happens here. Maybe you could see it coming when you saw the numbers. You know, you're like root 7 over 81. You're like 81, 81. Maybe you weren't happy to see 81 before, but you should be happy to see 81 now. Ooh, finish the list. 49, 64, 81, and 100. Can it get bigger than that? Only if someone's trying to torture you, I think. Though that's the complete list of what you're looking for here. So this becomes root 7 over 9. Much better. Much better. You might not be convinced, but that's much better than this was. Smaller numbers, I'm reduced it down, and the denominator is not a radical. That was the third rule. Let's go through the rules now. I promised I'd go back to the rules and make sure they made sense now. First one, the number under the root sign can't have perfect squares in it. That's what I did here. No perfect squares. Get that 9 out of there. Next one, no fractions under the root sign. I dealt with that here. I dealt with it 2 different ways here to get rid of the radical under the root sign, or to get rid of the fraction under the root sign. Last one, no radicals in the denominator. That hasn't happened yet. We apparently got to get to that. Okay. More time here. Brains running aground. I got these 3 examples and I'm done. These ones are a different mix of situations. I'll do this the long way, and hopefully you'll see the short way after I do it. 2 root 3 times 8 root 5. Here's what you do. Multiplication is commutative. I call it friendly. When everything's multiplied, you can do it whichever way around. This is what my kids are learning, that times tables, you only have to do half the times tables. After you learn 5 times 7, 7 times 5 is taken care of. They love that. They're excited about that. You remember excitement, don't you? When you were young, you were excited about things. So all I've done, I haven't done a thing here. You could argue I did not do a single thing here. But now that I've rewrote this in a new order, I know what 2 times 8 is. That's 16. And we know we're allowed to multiply 2 times 8. And we found out today, root 3 times root 5, we can write it as root 15. That's much simpler than the original expression. That's what we're trying to do here, is simplify. Final step. Do any of the suspects divide into 15? 4 divide into 15? No. 9 divide into 15? No. What's the next one? 16 divided into, no, 16 doesn't. Got to check them all at the end. Like, I don't like that part. Well, your calculator's there to lean on, to double check if you forgot. Maybe some of you are already using that for fractions. Do you do that? Do you cheat with fractions? Like, I don't know if this thing simplifies. 18 over 54. I forget about reducing fractions. I'll just pump into my calculator and I get the reduced fraction. See? That's the same thing we're talking about here. The only thing I'm asking you to do is to show the steps once you've figured it out. Okay? So this one is the same, isn't it? Isn't this the same question? It's got all the same numbers here. Okay, well, 3, 5, root 8, root 3. Some of you, after practicing the homework, will skip that step. You won't even write it like that. You'll just go, okay, multiply the 3 and 5 together. It's 15, and then root 24. Why is this question even in the examples? This doesn't show anything new. Isn't that the same question? That is not all. Oh no, that is not all, said the cat in the hat as he bounced on the ball. Check your suspects at the end. It's going to drive you crazy. Is there something divides into 24? And sometimes, I think the homework does get a little crazy with some of the numbers sometimes, eventually. But when you first start, it's like root 24. Okay, what are the suspects? You go back to your suspect list. If the perfect squares aren't familiar to you, does it divide by 4? Oh, it does divide by 4. There it is. 15, root 4, root 6. If you write the perfect square first, I think you'll find it a little easier to write the situation here. So I get 15 times 2 times root 6, which is 30 root 6. We call that better than 15 root 24. We've pulled as much as we could out of the radical. Radicals part 2, we'll see more of why we want to do those things. Right now it's like, okay, I guess it's better. Mr. Todd says it's better. It doesn't look better to me. It looks pretty much the same. You just have to trust me. Get everything you can out of the radical. But here's one that might motivate you a little bit. 12 minus root 63 over 3. This sort of looks like how quadratic formula ends up. What's quadratic formula? Well, I'll get to it. I'm not teaching quadratic formula. I'll reteach quadratic formula this year. But this sort of looks like what happens there. At first glance, there's nothing you can do. 12 minus root 63 over 3. But root 63 has one of the suspects in it. Does it divide by 4? No. What's the next suspect? 9. Does it divide by 9? It does divide by 9. You're like, oh. Now you want to rewind. You're like, I want to go back to grade 5 and memorize those times tables now. Maybe that was more important than I thought it was. You could still fix it. You know, get a little app. They got all sorts of little apps. Little grade 5 app, and you're in there going, I'm going to get my multiplication tables fixed up to 10 times 10. Really helpful. Your homework will go faster, actually, once you get them better. Till then, you might be going like this. You might go, okay, does 63 divide by 4? No. Does 63 divide by 9? Yes, it does. You might have to do that to check them all. It doesn't take that long, actually. So this can be broke up into root 9, root 7. You're unimpressed. But it is impressive because both of those things divide by 3. I can divide both those things by 3, and what I get is actually 4 minus root 7. I did that fast on purpose. I'm hoping that if you have a question about what I just did there in the last step, you ask it because I'm not sure what to say about that situation. That's either really easy or really hard depending on how your brain works. It could be that that's a problem. So you tell me, is that last step a problem? I looked and saw, oh, 3 does divide into both of these. So I'm just going to take each one and divide it by 3. If you want, all I did was divide it into 2 fractions. Said, well, that's equal to 12 over 3 minus 3 root 7 over 3. two separate fractions, and then just divided each one by 3. Only works if they both divide by 3, but this one happened to play it like that, which the quadratic formula often does. That's what we're getting ready for. I think that's chapter 3. A ways off yet. Do you have questions about that? 7 of 8. I thought there was only 7 slides. Is the 8th a blank slide? Is that why? Oh yeah, blank slide. Okay. Any other questions?